Example 22. Find the x values of all points where the function has any relative extrema. Find the values of any relative extrema for f of x equals negative x to the third plus 3x to the second plus 24x minus 3. So we're going to apply the first derivative to find this. So f prime of x is negative 3x squared plus 6x plus 24. We set our derivative equal to 0 so we can see where our function is increasing or decreasing by looking at the slopes of its tangent lines. So I'm going to divide every term by a minus 3, and I'm going to get x squared minus 2x minus 8 equals 0. I need the factors of negative 8. That will give me a negative 2. So that's going to have to be a negative 1 times 8, but that's not a negative 2. A negative 2 times 4, but that adds to positive 2. A negative 4 times 2 is what I'm looking for. So this is x minus 4 times x plus 2. Full that out just to verify that it's right. If I set them equal to 0, x minus 4 is 0 at x is 4, and x plus 2 is 0 at x is minus 2. So here I have two critical numbers. I'm going to put them on my number line. Negative 2 and positive 4. I'm going to find my test points. T equals negative 5. T equals 0. T equals positive 5. You can pick any number within the region. I just think 5s and 10s and 0s are easy, and that's usually why I pick those. So I'm going to have to do f prime for each of those test points, starting with negative 5. Negative 3 times negative 5 squared plus 6 times negative 5 plus 24. Type it straight into your calculator like that, or do the arithmetic. Negative 3 times 25 minus 30 plus 24 is a negative 75 minus 30 plus 24. So it doesn't matter if we actually know that number. This is going to be a negative. So this region to the left of negative 2 is a negative. That means my function is falling here. It's going down. Now the next point I need to evaluate is f prime of 0. F prime of 0, negative 3 times 0 squared plus 6 times 0 plus 24. It's going to give me a 0 plus 0 plus 24. Well, that's 24, a positive number. So this in-between region is a positive. That means it starts to climb again. And then I do f prime of 5. And I get negative 3 times 5 squared plus 6 times 5 plus 24. And I get negative 3 times 25, negative 75 plus 30, 24, and it's negative again. So it's falling here. So here we have a local maximum. Here we have a local minimum. And now we have to find those values. So now that we know where the local extrema occurs, we need to find the actual value of those. So when the function is changing from decreasing to increasing, you've got your local minimum, and that's occurring at x is negative 2. So our minimum's at negative 2. To find the actual minimum, we have to put that in the original function, not in the derivative. So you got to be careful about that. So it's going to be a minus and a minus 2 cubed, a plus 3 and a minus 2 squared, plus 24 times minus 2, subtract 3. Now, if you'll enter this carefully with the parentheses like this and always put your negatives in parentheses, you can type that directly in the calculator using the parentheses key. I'm going to just do it manually, so that's going to be a minus of minus 8, and a 3 times 4, a minus 48 minus 3 is 8 plus 12 minus 48 minus 3. That's 20 minus 48 minus 3. Negative 28 minus 3 is negative 31. So the minimum is negative 31 at x equals negative 2. Now, in the region where we got that the derivative was changing from positive and then in the next region to negative, that meant that the function was increasing followed by decreasing. So now we've got our local maximum. And to do our local maximum, it's going to occur at x equals 4. And I need to put that into the original function. So f of 4 is the opposite of 4 cubed plus 3 times 4 squared plus 24 times 4 minus 3. And you'll notice I put the parentheses here as well. I think it's just a good habit to be in. It'll save you a lot of issues with your signs. So negative 64 plus 3 times 16. 24 times 4 is 96. Subtract 3. Negative 64 plus 48 plus 96 minus 3. And I'll just type that in the calculator. So negative 64 plus 48 plus 96 minus 3 is 77. And that's our local maximum.